This is the simple microprocessor called the Microprocessor 3 of Rapid Prototyping of Digital Systems, Chapter 9. On the left, you can see the architecture of the computer system with the processor, memory, and input-outputs connected by the address bus and the data bus. The processor has a program counter, the PC, an instruction register, the IR, an arithmetic logic unit, the ALU, a memory address register, the MAR, the memory data register, the MDR, and a control unit. On the right, you can see the Vhdl code implementing this architecture. On startup, the microprocessor is reset, which sets the program counter to 0 and the accumulator register to 0. And then it moves into state fetch. So in state fetch, the instruction register is loaded from the memory data register, the program counter is incremented, and then the state is set to decode. In the decode state, it checks the first 8 bits of the instruction register and jumps to the execute state that it corresponds to. In the execute state, there are 5 possible instructions. Depending on which one was stored in the instruction register, it can add a memory address to the accumulator, it can store a value from the accumulator into a memory address, it can load the contents of a memory address into the accumulator, or it can move the program counter to a specific address if the accumulator is less than 0.
Alright, so this part is going to be explaining the waveform file. So on the left here is a MIF file, and this MIF file is essentially what we're going to be putting into the memory. So, hooray. This guy is 0, 0, so all of these are going to be placed into here, and you can see that in the output file. So the output file is right there. So we have the 0 to 10 that's being loaded into memory. See, the 0, 0 is being loaded into memory. What else? The 11 is being loaded to memory, which is into mem 11 of the AC, which is the address register. See, here's right there, the address register. Keep on going. We have the 112, which is being loaded into the data register, and it says that it's being stored into the data register right there. So as we just, so all of these get loaded into here, into these guys right here, and that's pretty much it. And then the output is being forced down here. So this is the output. So we're going to get a 0, 0 here because we're not doing anything. We're going to get an AA here because now we are adding. We're going to get a AA 0, 0 because we are now getting a AA 0, 0 here because we're doing a different one, and the FF55, which should be a FFFF, but it was changed in the MIF file because this is our custom MIF file, is indicating that the add instruction has worked and that 1 plus 2, and this is the end. It's awful. I don't know what I'm saying. It was 2 minutes. 2 minutes of rambling.
Was that what you were doing?
Yes.